Hello everyone, am I audible to everyone? Okay, fine. So, guys, I think we are live now, and let's start the discussion. Yeah. So now let's try to understand that, today we are going to talk about data science architecture, and we will try to understand first of all that what in all things comes into a picture. So whenever we are going to talk about data science, or whenever we try to design some kind of architecture, I think this is our second season that we are starting, because I think a couple of months back, so we have started with a data science architecture discussion, and we were talking about a different domain. So this is the syllabus, guys. So today I'll talk about why data science architecture is important, on what level of your a career, so you all will be able to apply this data science architecture, and what in all industry that we are going to cover. So we are going to add couple of a more domain in this data science architecture area. And yes, so end to end multiple use cases we are going to discuss, and this session is going to going to be alive for I think next 3 months. So again, depends upon your industry or depends upon your expertise. So you all will be able to leverage, or you all will be able to understand and learn that okay, how we design a solution, what in all different kind of projects are possible in a data science, and many more things actually. So many more things that we will be talking about, because see, the thing is now whenever we try to write some kind of a project, right, in our resume, right? So let's suppose if I wanted to mention some kind of project, so we all are working in some of the domain, right? So if I'm talking about, okay, so I think people are saying that voice is there's an echo or something. Let me check. Okay, now I think it should be fine. Okay, is it fine now, guys? Okay, so let's check. Let's wait for some time. Just let me know, guys. If it is fine. If it is okay with everyone. Okay, voice is not clear. I don't know what is a problem with the tool, because I'm using OBS, and for the very first time, generally I use Zoom, and Zoom is pretty much fine, but this one is having some sort of issue, I think. Okay, is it fine now, guys? Okay, people are saying it's better now. It will it's the first time for me. I'm on OBS. Generally, I use Zoom. So in Zoom, so we don't face such kind of a issue, such kind of problem at all. Okay. No, guys, I'm not using Zoom actually. I was using Zoom, but yeah. Okay, fine. So people are saying that it's better now, right? Okay. So fine, guys. Let's start with the architecture discussion, and we have to discuss a lot, right? And yes, so like I have said in yesterday's class itself, so this is the roster that we have, and yeah. So we have already created a playlist for all the sessions that we have taken yesterday, and even for this one, so the playlist will be created for sure, and all the videos will be updated in a respective playlist. Timing for this class is going to be 8 to 9 p.m. IST on a Monday, on sorry, not on Monday, so on Tuesday, on Wednesday, and on Friday. So these are the 3 days on which I'm going to talk about a data science architecture, and yes, so we will try to understand many more things over here in this particular one. Yeah. So fine, guys, let's try to start. So first of all, we will try to understand that what is a data science architecture, right? Why it is important, and how you will be able to leverage all of these capabilities, and how you will be able to add all of those things into your resume. So whenever you will try to prepare your a resume, so how you are going to mention all of those things, right? So yeah, so we all will try to understand this particular part. So let's try to understand. Okay, so let me zoom out. I have just zoomed in because, okay, yeah, fine. So fine guys, first of all let's try to understand a syllabus, that what and all things that we are going to discuss, that we are going to talk about. So syllabus wise, right, so we have a plan to cover a different kind of a domain over here. So the first of all, we are going to cover a supply chain domain, that like how in a supply chain domain we all can try to implement, or what kind of a project, what kind of a machine learning or what kind of a deep learning project that we can implement. So first of all we'll see supply chain, and then in a second place, so we are going to talk about like a retail industry. Again, whenever we are talking about a supply chain industry, so we are going to cover a variety of a different kind of a supply chain use cases, not a single one. Last time we have already discussed one, so we'll try to cover that as well, because last time I think I have talked about like one of the my project, right, which I have done for one of my client. This time, so we are going to talk about a multiple supply chain project, and that too in a machine learning as well as into a deep learning. Last time I think I have just covered a supply chain just with respect to a machine learning. Okay, now so in a second place, so we are going to talk about like a retail industry, how you what and all different kind of a project that we used to build, that we used to develop in a retail industry. And then we are going to talk about like a healthcare industry, and then we'll talk about like a security and surveillance. Security and surveillance is one of my favorite, you can say, even in my company, so we used to work on a multiple security surveillance project, and we have a different kind of a client, whom we are trying to cater these things. So we'll talk about most probably those projects. And then the another one is industry, insurance industry, like a problem and its solution designing. So again, many of you must be working like a insurance industry, so we'll talk about that as well. And then there is something called as a banking industry problem, so we'll try to discuss a banking, finance industry, telecom industry, right, a problem statement and its solution, oil and gas, and a transport industry, sales industry problem, or education industry problem that we are going to cover. And then automobile industry, manufacturing industry, networking industry, and again so HR, right. So I think in every companies you will be able to find out HR, so how we can try to build like a generation 4 based HR system. So again into deep learning as well as into a machine learning. So I'll try to introduce like a more of a deep learning based solution over here in this HR based, like a HR based solution architecture designing. And e-commerce, I think we all are using like a somehow in some way, so we all are using kind of a e-shopping, e-cart, or you can say like a kind of a app by which we will be able to order something, some of the like maybe grocery or maybe some kind of inventories we can try to order. So we'll try to talk about all of those things. And then like a IT networking, and then airlines industry and operations on a various problem based on the AI solution designing. And then in a cyber security or network security, so how we can try to implement this AI solution. So this is the syllabus guys that we are going to cover. On top of that, so we are trying to add couple of more domains, so for sure we will try to add it. And last time I think this was the session that we had conducted for a 3 to 4 week, but this time it is going to be like a it is going to like a be like for 3 months. So we are going to expand these things. And like I said, so last time most of the things I have discussed just with respect to a machine learning, but this time so we'll try to understand and we'll try to discuss all of those things with respect to a machine learning, deep learning, as well as NLP, right. So again in some of the problem statement in some of the industry solutions, so we'll try to add a couple of reinforcement problem statement as well. And this is how we are going to cover each and everything. So fine guys, let's try to understand. So first of all, why data science architecture is important, how you all will be able to leverage this particular capabilities to build your resume, to talk about your story, to talk about like your experience in a interview, right. So see, the thing is, whenever we try to get a problem statement from a client, right, so in a very first place, right, in a very first place, we never talk about a solution. So whenever client will try to discuss, or suppose if I'm trying to build some kind of a product, right, so we don't start building a solution immediately. First of all, we try to understand the potential, we try to understand that okay, so what in all data points which I will be able to capture. And then we try to understand that okay, so if data points are fine, so whether I'm able to get a required data or not, that is also important, right. Because the thing is like you have a data, that doesn't mean that you will be able to build a solution. A simple thing is, right, if client is giving you a data, and if they're asking you that, okay fine, so I'm looking for this solution, so always it's not possible to like build a solution immediately. So we never design or we never start building a solution immediately. As a learner, yes, what happens is like if I'm getting a data maybe in an Excel sheet or maybe somewhere, so at that point of a time immediately we start working on those part. But in a real time industry, no, this is not happens at any point of a time in a real time industry. So we always try to like talk about a data, we try to talk about like a data points, and then we start building a solution. Doesn't matter what kind of a solution that we are trying to build, what kind of a problem statement that we are going to solve. So this is something that happens all the time, right? Now, so like and again, so whenever we try to talk about a solution, so it's not like just a data part or a data points which comes into a picture. So apart from a data, there are a various things. Like a first part is a data, that is like a completely fine, the first part is a data. So if I'll talk about a number one, so yes, a data is something that we use, but a number two is other infrastructure, right? So let's suppose if I'm talking about other infrastructure, so in that case DevOps will come into a picture, right? And I can say like cloud will come into a picture. Now on top of that, I can say like a UI development, right? It can be like a mobile application, it can be a desktop application comes into a picture. Then on top of that, so like a server, a variety of different kind of a server comes into a picture. Again, the way we are getting a data, right? So let's suppose if I'm receiving a data into a streaming mode, or maybe if I'm receiving a data into a batch mode, or maybe a real time, near real time, or in a batch mode, right? So whenever we try to design or we try to build a solution, so it depends upon all of those things a lot. So like I said, data is fine, right? So data is fine, you will be able to like think of some kind of a, some sort of a solution, right? But no, whenever we try to look after the end-to-end solution, so data is not the only factor which we have to take care of, right? And again, so on top of that, deployment. So sometimes we try to deploy these things in a local server, sometimes we try to deploy all of those things in some cloud server, sometimes we try to deploy all of those things into a mobile application by using, not by using an API, by hosting a model, or by like integrating a model in our Android or iOS application itself. Or sometime we try to use like a edge devices, right? So we try to use a edge devices, and then inside the edge devices we try to integrate all of our solution. So these are the things that happens, these are the stages that we always try to cross. And then on top of that, so we always think, or we always try to develop what, a dashboard. We always try to develop a dashboard. So again, we have a multiple dashboarding tool, we have a multiple dashboarding libraries as well. So we have to pick and choose that which dashboarding libraries I'm going to use. Now, so again, the last but not least thing is a model building approach, right? Model building approach. So whenever we are talking about a model, so sometime what happens is, let's suppose if I have a tie-up with a Microsoft or Google, when you will be a part of industry, so for sure every a big market player, right, or every big market player, so they try to like do some sort of a tie-up with some of the industry, some of the like a market player. Let's suppose Google, Microsoft, or AWS, they are using their services. So sometime what happens is we don't even build a model, right? As a learner, as a beginner, what happens, like whenever we get a data, right, so immediately we start building a model. But no, on an industry level it never happens in this way. So we try to like build, so we try to like build a model sometime, and sometime, right, we try to use already like a predefined services which is available with someone. So this is something which happens in general, right? So whenever we are talking about like a data science architecture, and we have to take care of each and everything while designing a solution. So suppose if you are working on a lead level, suppose if you are working on a manager level, so at that point of a time, you don't like, you just don't need just a like understanding about the algorithm or understanding about the mathematics behind that, but also on top of that you need all of these understandings as well. Unless and until you don't have this understanding, you will not be able to design end-to-end solution. For sure you will get stuck at some point of a time, and all of these things must be very clear. But in general, I have seen a trend that person who is trying to pursue a data science, right, or person who is trying to make a transition into a data science career, so they just talk about a data, right, they just talk about a model building, which is not enough, which is not sufficient, right? So you have to talk about all of those things, and then only you can say that fine, I will be able to build, I will be able to develop a better architecture, better design, better solution, or maybe you can say that a robust solution I will be able to build. And keeping these things in a mind, because most of you, right, most of you have asked me a question even in past that so I'm from supply chain, or maybe I'm from healthcare, or maybe I'm from like a aviation domain, I'm working into finance, so what kind of a project I can write, right? What kind of experience, what kind of expertise I will be able to showcase, or like what I should write in my resume, right? So if I'll have to create, if I'll have to like accommodate a completely new project, so in that case will I be treated as a fresher, right? So these are the concerns we always had, right? And your concern will not be gone, so unless and until, right, unless and until you are not aware about all of those things are solution designing. And again, at the same point of a time, you will not be able to express yourself, right? You will not be able to express yourself, because on that level, right, on that level, if you're going to give an interview, so person can ask, your interviewer can ask any kind of a question from any of these part, because it will be your ownership, it will be your stakeholding, and yes, you will be responsible for each and everything, so you have to give an answer. It doesn't mean that you have to work in all of those areas, but yes, at any point of a time you should know about that, and you are supposed to talk about these things. And this is what we are going to discuss, this is what we are going to talk about in our data science architecture. So let's suppose, right, so let's suppose if I'm going to like start with one of the architecture. So here you can see that these are the architecture that we have. This is the architecture of one of the project which I have done, and you will be able to see that there are like a multiple labels, there are multiple layers which comes into a picture whenever we are talking about the architecture, like a data source, right, a data integration layer, data processing layer, data storage layer, analytical functional layer, or presentation layer, administration layer comes into a picture, MDM comes into a picture. So you can see very clearly that there are a variety of things, right? There are a variety of the things which comes into a picture. And unless and until, right, so unless and until you are not sure about each and every layer, it will be very difficult for any one of you to design or to build a solution. And this is what we are going to discuss, this is what we are going to study in this particular session, end to end. So first of all, let's talk about our data source. So what is our data source that we can have, or what and all different kind of data that I will be able to get from our different data sources, and then I will be talking about a story of this project. Yeah. So let's suppose if I'm working in some of the project, right, so it could possible, right, it could possible that we have to pull a data from maybe some of the server, right? It could possible that we have to pull a data maybe from some of the cloud environment. It could possible that I will have to pull a data, right, maybe from some kind of a databases. Now in case of a databases, it can be a SQL, it can be a no SQL kind of a databases. It could possible that I will have to pull a data from sensor. It could possible, right, that I will have to like pull a data maybe from some kind of a satellite device or some kind of a telematics device, right, some kind of a telematics device. So again, right? So again, if I'll talk about a data source, so in general, as a beginner, when we try to learn something, so at that point of a time, right? So we used to load a data maybe by using a CSV, maybe by using some kind of an Excel sheet, or maybe we try to like a churn a data from some of the website, or maybe, right, we try to use a JSON data max to max, right? But in a real time, right, in a real time, this is not a kind of a situation that you are going to face when you are talking about, or when we are thinking of designing an enterprise grade solution. Like I said, so it could possible that data can be available in a client local server, right? And server is nothing but it's a system. So even we all are using system, right? So server is nothing but it's just a system. So maybe it could be a local server, and it could be a remote server from where you will have to pull a data. It could possible that you will have to pull a data maybe from like a some cloud storage. So I can say like a S3 bucket as like a AWS, or maybe if I'll talk about Azure, so maybe from Azure blob you will have to pull a data, or maybe from a GCP storage you will have to pull a data, right? Or maybe some kind of a databases we have over a cloud, and from there you will have to pull a data. So it could possible. Now, so again, if I'll talk about a SQL or NoSQL DB, so in case of a SQL, it could be possible that you'll have to pull a data from Oracle like a databases, or maybe from MySQL databases, maybe from a SQLite, or maybe like a from a DB2 you will have to pull a data. If I'll talk about a NoSQL, so it could possible that you will have to pull a data from a MongoDB, you will have to pull a data from maybe like a Cassandra, or maybe like a HBase, or like a RAC, or maybe like a Neo4j, or maybe like InfluxDB or Google BigQuery table. So these are the databases which has been used widely across an industry, right? And it could possible that you will have to pull a data, or maybe from some of the sensors, right? Some of the IoT devices you will have to pull a data, or maybe some of the movable telematics devices which ejects up like a real-time data set. So from there you will have to pull a data. So there are a variety of the sources that you can encounter, or it could possible that there is some kind of a streaming like a framework that you have, like a Kafka, right? So if I'll talk about a Kafka, so it could possible that I have some kind of a like a streaming framework, and there are thousands of, right? So I have just given you a high level like idea, right? So once I'll get into a project, so I'll talk about what databases we have used, what kind of a cloud storage we have used, what kind of a server or telematics devices, or maybe a sensors that we have used. But as of now, I'm just talking about a in generic approach, right? So if I'm talking about an in generic approach, so it could possible that I'll have to pull a data from a variety of resources, right? And in a single project itself, it could possible that we'll have to pull a data from your website, maybe from your Android application, maybe from a Google Analytics, right? Or maybe from the Adobe Analytics, you will have to pull a data. And yes, this is what we do all the time, right? So you are supposed to understand. So it's completely fine if you don't understand a cloud, if you don't have a knowledge of a DB, sensor, telematics, it's completely fine. There won't be any kind of a issue, right? But at least we should know that how to establish a communication. Unless and until you are not aware about this particular fact, that how to establish a communication, so for sure you are going to face some kind of a issue. Or maybe you will be in chaos that, okay, so I don't know how to like pull a data from there. Now, so these are the just a high level system from where you can try to pull a data. The second thing is, right? The second thing is that whenever you are trying to pull a data, so your data, right, that you are going to get, so you can get your data maybe in a real time, or maybe like near real time, or maybe into a batch, right? So now, what is the meaning of this? What is the meaning of real time, near real time, or batch? So whatever sources which I have listed down over here, right? So whatever sources that I have listed down over here, so it could possible that you will have to like stream a data, right? That is called as real time. Means it should be a continuous streaming. Suppose if I have deployed like a certain kind of a sensor, maybe in an agriculture area, agriculture field, right? Or maybe if I'm trying to build a solution, so which which will be able to which can be used to monitor or observe an entire wildlife sanctuary, right? So wildlife sanctuary, which is very much difficult for a human being to monitor and to track each and every animals who is living inside that particular wildlife sanctuary. So maybe I need some kind of a sensor, I need some kind of a device, IoT devices, which will be able to stream a data. And then once I will be able to stream a data, so I need some kind of a system, right? So I need some kind of a system by which, right, so by which I will be able to process those data, I will be able to generate, identify, detect, segment, track each and every animals or each and every activity inside a wildlife sanctuary, right? So in that case, it could possible that I will have to pull a real time a data set. Maybe if I'm trying to build a solution for oil and gas field, or maybe for a oil and gas pipeline, right? So even in that case, so you will have to pull a real time data, you will have to pull a streaming of the data. So there will be a multiple system which comes in between, and which I will be talking about with respect to this project. So yes, I'll be talking about, because almost all three variety of the data we have used in this particular project, right? And there was a multiple data sources. So that's the reason, so I always love to talk about this particular project in a first place. So whenever I start with the data structure architecture or data science architecture, my bad, so data science architecture, so we always start talking about this particular project. Yeah, so real time simply means that if you are trying to stream a data continuously without any interruption, right? Second thing is near real time. Now what is the meaning of this near real time? So a simple meaning of near real time is, so let's suppose it's not a continuous one, there is some lag, there is some breakage of 1 second or maybe some microsecond or millisecond, right? And maybe if we have a small delay, right? So that we can name as a near real time. And then there is a third mode by which you will be able to pull a data, that is called as a batch mode, right? So batch mode is nothing but, it could possible that I have to process my data once in a day, twice in a day, maybe 10 times in a day, or maybe once in a week, once in a 3 month, once in a year. So this kind of a situation, right? So this kind of a situation is called as a batch mode, right? So this is something called as a batch mode. Basically, when we can try to schedule a different kind of a processing, right? And whenever your batch is scheduled, so at that point of a time, so it will try to give you some sort of analytics, it will try to give you some kind of a information, right? So that is something called as a batch mode. So again, so in terms of a data, so data source is important. Now in what mode we are getting a data, even that particular things are important, because so you are going to define your entire server, your entire architecture, your entire architectural component like a databases, processing tool, right? And many more things on top of this real time, near real time or batch. It's not like whatever solution which I have built for a batch mode, the same solution is going to work for a real-time data as well. No, it never happens. And that's the reason. So we are supposed to take care of these things, whether I'm trying to build a machine learning solution, or I'm trying to build a deep learning solution, or any kind of a solution which I'm going to build maybe with respect to a AI, artificial intelligence, by using a data science various components like a machine learning, deep learning, NLP, computer vision, reinforcement, or maybe a statistical model I'm going to build. So these are things which always plays a very important role, right? So whenever we try to talk about, or whenever we think of doing some kind of a solution designing, some kind of a architectural designing, so it's very important things that we are supposed to take care of. And unless and until you are not going to take care of these things, it will be a problem, and you will not be able to build a robust solution. So we are supposed to understand these particular factor. Now, so let me take some question from a live audience, and then we will try to again get back to our discussion. So fine guys, if you have any kind of a question, you can try to post it in your a live chat, and we will try to answer couple of questions, not all maybe. Okay, what is telematics? So I will talk about that because when I was a part of Verizon, so I was working into a telematics division. It was basically like a autonomous car division. We were trying to build a small application for that particular division. So we'll talk about that now. So is there any prerequisite? So no, not at all. There is no prerequisite. Okay, so sir, is the pulling data and data scrapping is same? No, not at all. See, data scrapping is something like suppose if I have a website, right, and then from there if I'll have to churn the data, or maybe suppose if I have to do if I have a RSS feed, I think you must be aware about the RSS feed. So from there if I'll have to pull a data, so that is called as a biv, so that is called as a scrapping. But this is basically like whenever we talk about a data pulling operation, so data pulling is something different, so where we try to connect with our a particular server or maybe a particular databases by using some set of a driver, and then we try to pull the data. So that is something called as a data pulling. Okay, so please explain a batch mode again. So see what happens is, so it's not like your model will keep on receiving a data, right? Your model will keep on receiving a data. Sometime what happens is like you will have to use a scheduler. Again, those who are not aware about scheduler, so it's completely fine. When I'll talk about one complete project over here, this particular architecture diagram, once I will be talking about, so plus this architecture diagram where I'm trying to cover like all end to end, I can say different tools, technologies that we have used. So basically like a batch mode, right? So batch mode is nothing but that whenever suppose if I have to schedule in such a way that maybe once in a day, or maybe twice in a day, or maybe once in a week, if I have to use my model, or I have to do some kind of a prediction or some kind of forecasting, right? So that mode is called as a batch mode. Okay, so is this the first class for data science architecture? So yes, this is the first class for data science architecture. We are just going through our induction, nothing else. So will there be deployment related info? Yes, we are going to cover that as well. I'll talk about all of those things, like in what mode we have deployed, what kind of a solution, so that it will be helpful for you to understand and to understand each and everything, and to understand the life cycle of end to end like a data science, right? And you all will be able to use it, you all will be able to implement it when you will try to design some kind of a solution. Does a data scientist need to be a data engineer? No, not at all. This is not required. What is difference between SQL and NoSQL? So I think we'll talk about that. Yeah. Okay, so give me one example for a near real-time data. Okay, so generally what happens is in a telematics devices, right? So let's suppose if my telematics devices is connected to my server, right? So sometime we try to for some of the packets, right? So for some of the packets that we used to receive, so we try to define that, okay, fine, so I will not receive this packet like in every as a stream. So we can receive this package maybe once in a 1 second, or maybe once in a 2 microsecond or millisecond. So that kind of example I can give you with respect to a near real time. So it's a kind of a real time, but yes, there will be some kind of a lag. Okay, now, so now let's try to understand about like a story behind this project. So I'll just try to give you a glimpse of it, right? So I'll just try to give you a glimpse of it over here, that what was the kind of a project which I was working on, and what we have done, what kind of a solution that we have designed. So I'll try to cover a little bit of those things. So here in this was basically a supply chain project that we have designed, or that we have developed. So now, okay, so this was basically a supply chain project that we have developed. So it was a SCM project, you can say. So SCM. supply chain management project that we have developed or that we have designed. Now, so this project was basically designed for an automobile industry. We have designed this solution. Now, so what is a requirement, or what was a kind of a problem or kind of a challenges that my client was facing? So first of all, let's try to understand, because this is where the story of any project is going to start. So first, in a very first place, we always try to understand our pain points of a client, and then we try to understand our data, whether it's available or whether it's not available. If it is not available, then we can try to derive our data from what and all sources. And again, so business understanding, functional understanding comes into a picture. So this was, as I said, that this was basically a supply chain management project from a automobile industry, because supply chain is a part of many industry, I can say, from for every industry, every manufacturing industry, like try to they have like their own robust supply chain management system. Now, so it was a SCM, it was supply chain management, E2E, end to end aftermarket project. So this was the kind of a name of this particular project, right? So now, what is the meaning of that? So supply chain management, nothing but it's a kind of a domain, right? E2 is nothing but end to end, and then like a aftermarket. So it was basically an aftermarket supply chain E2E project that we have developed. Now, what is the meaning of aftermarket, right? So you must have seen that we always try to buy, we always try to buy some kind of a vehicle, right? So let's suppose if I'm trying to buy a vehicle from a Toyota, right? So I'll try to go to a Toyota showroom, and then I will do a registration, and maybe I'll wait for my loan to be processed, or maybe I'll try to buy a vehicle then on that day itself. And it could possible that documentation is going to take some time, registration is going to take some time, right? And once this entire process is done, right, so we used to get a vehicle. So this is the procedure by which we try to apply for any of these vehicles. So whether it's from Toyota, or maybe from a Tata, or maybe from a Maruti, or maybe from a Mercedes, maybe from a Audi, or anywhere, right? We follow a similar kind of a thing. Now, so what is a meaning of this aftermarket? This is what we are trying to understand. Now, so we try to purchase, or we try to make this kind of an investment, right, only for once. We try to invest our savings to purchase a vehicle. But once we'll be able to purchase a vehicle, so in maybe every 4 month, or maybe in every 6 month, or maybe in every 8 month on an average, so we try to go for a servicing. And again, so whenever we are going for a servicing, right, servicing of a vehicle, so it could possible that I will be looking for maybe a brake shoe, or maybe a seat cover, or maybe some kind of an engine part, maybe a battery replacement, or maybe I will be looking for them to fix my particular problem, right? So you try to purchase a vehicle for once. This is one time investment that we used to do. But this is something that is a recurring investment that we used to do all the time, right? And by the time, so unless and the time, by the time, so we'll try to use this vehicle, so for sure we'll try to keep on investing something, maybe sometime, so because of dent, so we'll have to ask them to fix it, right? And for sure they are going to charge us. And maybe I'm looking for some kind of a parts replacement, maybe a gearboxes, maybe a steering, or maybe a brake shoe, or maybe a clutch, or any part, right? So any part in an engine, so we can ask them for a replacement or for a repairing, right? So now this market, so this one time market generates 50% of a revenue for almost every kind of a automobile manufacturer in general. I'm just talking about these things in a generic way. So this one time, right, so this one time purchasing always generates a 50% of a revenue. But 50% of the revenue they try to generate from aftermarket, means once I will sell you a vehicle, right, for sure you will come to me for a servicing, right? So suppose if in some of the area, if a road is too bad, if like a rainy, there is a rainy condition, or some kind of a things which has happened, so in that case for sure people will try to visit a particular nearby service center more frequently, right? So they will try to like a service, or they will look for a servicing more frequently in those particular area. But yes, this is something which is a recurring one, right? So by the time you will drive your vehicle, so for sure you will keep on looking for some kind of a services, and right. So and this is where they generates a rest of the 50% of revenue. So in a recurring order, they used to generate a 50% revenue. So it's a huge market, right? It's a huge market that they have in a automobile, that is called as a aftermarket. So for any automobile manufacturer, right, or any automobile like a supplier, so most of this automobile like a industry or a big player, so they don't manufacture all of those parts by themselves, right? So they always try to give a contract to a third party vendor. So for any of them, right, so aftermarket is one of the biggest market, but at the same point of a time it's one of the complex market as well. Because one time if I have to deliver a vehicle, I'll assemble all of those parts, I'll give it to you, it's completely fine. But in this case, right, but in this case it depends upon a reason, it depends upon a local condition, it depends upon like how many people are there who is using that particular vehicle, it depends upon how many service center that we have. Because just to build one single vehicle, in some of the vehicle including a small nut bolt and then washer and then a pad like a gear shoe or something like that, right? So almost, right, so almost just to build one particular vehicle, right, one particular vehicle end to end, we need n number of different parts. So let's suppose for example, if I'm talking about one single model, right, one single model of Toyota, let's suppose I'm talking about like a Innova, right? Innova. So if I'll talk about Innova, so in that case to build to assemble one single vehicle, so maybe I need, right, so maybe I need a 10,000 different part just to build one single model of a Innova, like a once. And again, so you will be able to find out that there are multiple variants, right? There will be a multiple variants that you will be able to find out. So one variant will be on top of like a petrol and diesel, the another variants will be again like a some variant on a low level starting from like a base model to a high variance, right? So you will be able to find out a multiple variants in a single class of a vehicle itself. And Toyota is not the company who is just trying to manufacture Innova. So Toyota used to sell many other vehicles as well, right? So Toyota used to sell many other vehicles as well, and this is where the problem is. So let's suppose in Innova like itself we have, let's suppose, 8 variants, and again, so in every vehicle let's suppose we have 8 variants, and let's suppose so in total Toyota is having like a in last 20 year, so let's suppose on an average, so last 20 year, so Toyota has released maybe more than 500 different varieties or variants or model different like a vehicle, right? So Toyota has released like a 500 different vehicles. So if you will try to calculate, right, and suppose if I'm trying to provide some kind of a service, right, it's some kind of a service for a Toyota, so for sure I'm supposed to maintain these many parts at a time, which is near to impossible, right, which is near to impossible. And again, if I'll talk about Mercedes-Benz try to manufacture a truck, bus, car, SUV, right, a compact SUV, and many more things, right? So everyone try to manufacture multiple things, and again inside a single model itself there will be a variance that you will be able to find out, right? So these many parts you are supposed to maintain at any point of a time, on an average I'm just talking about, right? So again, just to manufacture one single vehicle, in some of the vehicle, if I'll talk about a truck, so there will be a lakhs of part, including a different kind of a nut bolt that we are going to use, right? So in some of the vehicle it can cross like 100k as well. As of now I have just written 10k over here, but it can cross 100k as well in that case. So basically, right, basically as a supplier, what will be my pain? So my pain point will be to store all of these parts at a time in one of the warehouse, right? So how I will be able to solve this problem, right? This is the problem, this is the core area, this is the core problem. There are many more problems as well, so I'll talk about almost like a 8 to 10 problem with respect to this one, this particular architecture. So it was not just a only one problem that we have solved, there was a multiple problem that we have solved. So we'll talk about all of those things. But here, right here, as we are discussing, so like I said, so there are a variety, there are like a variety of a different kind of inventories, a variety of a different kind of parts that you are going to need just for one single automobile manufacturer. It's near to impossible to store all of those different inventories in a single warehouse or maybe in a single service center. But but still, right? So but still, there is a 50% of market, it's a huge market, right? So if I'm not able to supply, right, so for sure person will go to a third party provider, or person will go to a third party vendor, and in that case it will be a loss for me. So I will end up decreasing my revenue in that particular case, and which I don't want, right? Which I don't want, which I don't afford of losing this much of percentage or this much of revenue. So this is where machine learning, this is where AI, this is where data science can come into a picture, and then it can rescue to increase our revenue and to solve many other problems which I will be talking about. So this was a very first problem, maintenance and management of our inventory and maintenance and management of our supply chain of each and every inventories, right? So hypothetically speaking, right, hypothetically speaking, what if I will be able to predict, what if I will be able to forecast that, okay, so this is the number of this inventory that you are going to need in next 3 months or maybe in next 1 month. This is the total supply that you have to maintain, right? And that too, if I'll talk about India, right? So India itself is a huge region, right? So maybe let's suppose if I'm talking about like a north, south, east and west, right? So if I'm talking about all the part, so again, the climate, road condition, right, a number of people who is having this kind of a vehicle is completely diversified, it's completely different. So it's not like whatever prediction forecasting which I'm trying to do for one reason is going to work for all the reason. So I'm supposed to find out all of those things based on our different geographies. So it could possible that for one of the geography situation will be different, for other geographical conditions situation will be different, right? So I will have to and again, so it's not like in every area, right, in every area, so we have like a production unit which will be able to manufacture all of those things. It could possible that I have a production unit in some of the area, and then I will have to arrange a logistic from one area to another area. So again, there will be an issue, and you are supposed to you are supposed to maintain a logistics as well, which I have mentioned, right, which I will be talking about for sure. So there are many factors, which comes into a picture, and reason wise we were supposed to do a prediction, reason wise we were supposed to do a forecasting, and not only a region wise. So let's suppose this is one region, and in this region it could possible that there will be a multiple warehouses you will be able to find out, right? So there can be like 100 warehouses in some region there will be like a 200, some region there will be a 50 warehouses, right? So again, all those warehouses regional condition we are supposed to understand, and then only based on that we will be able to do a prediction, we will be able to do a forecasting. We have to even depends upon the local climate condition, right? We are supposed to understand a local political condition as well. So if there is a lockdown in that area, if there is a curfew in that area, it could possible that if because of curfew some damage has happened, so in that case maybe supply I have to increase, or maybe there was a peaceful curfew, so in that case I'll not have to I'll not be able to sell it. So even if I'm going to send my inventories in that particular warehouse, maybe I will end up doing nothing, right? So many factors. So whenever we talk about a data, right, so many dimensions comes into a picture all the time, right? Let's suppose if I'm trying to maintain a supply, but in that area I don't have a user, right? I don't have like many buyers, many manufacture, like many people who have like there are like people are not using my brand over there. Maybe people used to prefer a different kind of a brand over there from a different like automobile industry. So many things comes into a picture. So whenever we talk about, right, whenever we talk about this a supply chain in a automobile, and it's a huge chaos, right? It's a huge chaos, and this was the kind of a problem that our client was facing when we were trying to solve this particular problem statement, right? So it's a huge industry in itself, right? And even now this industry is not that structured. So for one of our client, so we have built a solution, we were trying to provide a solution for this problem statement. Now on top of that there are other problem statement as well which will come into a picture. So like the other problem statement is something called as a spike order, right? So sometime what happens is, let's suppose I'm a like a supplier, and let's suppose you are a buyer, right? So in some of the month, right, so let's suppose I'm a supplier, right, and then there are multiple buyers. So there are multiple buyers who used to buy maybe 100 piece of brake shoe in every month, right? So everyone is trying to buy 100 piece of brake shoe in every month. In some fine month, let's suppose one of the buyers said that okay, so this month I need 500 brake shoe of this particular model, right? So the regular supply was 100, right? Now this particular buyer has asked me to supply 500, maybe because of some condition, right? Maybe because of a bad raining condition, or maybe because of anything, right? So that particular buyer has asked me, okay fine, or buyer means simply like a service center, I'm just trying to refer. So service center has asked me that, okay fine, so like no, this month I need like a 500, so like 100 will not work for me. In that case your order has spiked immediately, right? Your order has spiked immediately, and if you are not able to do a forecasting, right, if you are not prepared, if you are not ready beforehand, so in that case, right, so in that case you will not be able to use it, right? Or you, in that case, you will not be able to maintain an order, you will not be able to maintain a supply, and again so you will end up creating a disaster, right? So there is something called as a spike order prediction. So a spike order prediction even we have done, order cancellation prediction we have done. So likewise, like I told you, so there are 8 to 10 problem statement which we have solved, right? And I will be talking about all of those things. So guys, this is just like I was just talking about a brief overview. I just talking about like a brief idea about like what is a data science architecture, what and all things that we are going to discuss, we are going to talk about into data science architecture. Many more things will come into a picture. So this is just a glimpse of it. Like I said, so industry wise, variety of industry we are going to cover. So we'll be talking about many more things going forward, that what happens across the industry, and then what kind of a solution that we used to design, we used to build, whatever we think is correct or not, many more things which will come into picture. So this is it from my side, guys, for today's class, and stay tuned for the next upcoming classes. Like I said, so this class is going to happen on like every Tuesday, Wednesday, and a Friday at this particular point of a time, 8 p.m. to 9 p.m. IST, and I will be talking about a multiple different kind of a solution. This today was just an introduction class. We had just talked about like a simple what is the meaning of I will say a data science architecture, why it is important, what kind of a data sources we can use, what is the data mode that we use to receive. But yes, on top of this, many more things which we will try to add, right? So just stay tuned for those things, and see you again in the next class. But yes, before concluding this class, let me answer some of the questions from a live session. Yeah. So thank you, Aditya, and please make a project in automobile industry, sir. We already have a project, so we don't have to make it, Arun. Yes, why we can see why we can't get syllabus. No, you will get a syllabus, so not an issue. It will be updated in the description. We have started with the multiple classes, so just within 2 to 3 days everything will be on track. please provide a document. So whatever document I'm going to use, so it will be updated in a respective like a video itself. Yeah, so those things will be available. So document and everything is available for you all guys. You're not supposed to worry about document or like anything that we are discussing. So everything is open sourced, and even my lectures and all the documents. So you can just try to take advantage of these things as much as possible. We don't have any issue. Agriculture also we have a project. So we have like a project on everything, I would say. So we have like a huge set of the project. It's difficult to discuss in front of all of the audience, because sometimes what happens is it's a bit difficult to make them understand on that level. So that's the reason. So we always try to start from some sequence. So do we need some prerequisite? No, there is no prerequisite for this one. So should I join your DLCV like a course? Yes, anytime. So you can join. You can connect with our support team, and then they will help you out, right? So just feel free to connect with our support team for that one. Fine, guys. So if you have liked this session, so please hit like, and just try to share these things with everyone, right? So everyone who is interested, everyone who is trying to make a transition into a data science, or everyone who wanted to understand that how things works actually on an industry level, right? So that we'll be able to spread as much knowledge as possible, and we'll be able to reach out to as many people as possible. You just need to share these things with everyone. Yeah. And with that, thank you so much, guys, and see you again in your next session.